Okay, this video is meant to guide you through homework 3.1. So we're going to consider a competitive market for used copies of Greg Mankew's textbook Principles of Economics. The daily demand for books is given by the equation willingness to pay equals 150 minus Q, while the daily supply of books is given by the equation willingness to accept equals 10 plus Q. So we're going to use this information to draw a buyer's demand curve, seller's supply curve, to find the equilibrium price and quantity of textbooks, to think about an out of equilibrium price, think about why the equilibrium price is actually a Nash equilibrium, and to measure the consumer and producer surplus of this market. Finally, think about whether or not the competitive equilibrium is efficient and fair. The final part, which has us consider increase in demand for textbooks, is something I'll leave to you to work through on your own, but you'll use exactly the same logic we're using in A through G. It's just another example of what to do. So this problem is easiest if you just work through it with a piece of paper and a pencil. And I've got my digital paper and pencil. Right, so what we're going to start with is just a vertical axis for I'm still learning how to use a digital piece of paper. That maybe it'll get easier over time. So we have a vertical axis. That, of course, will be our price axis. And then we're going to have a horizontal axis. I encourage you to use a ruler as well. It makes the whole thing, I think, a little easier. Right up here, we have price. Down here, we have quantity. Right? And so our first step is to draw the demand curve using the willingness to pay function, where we know what someone's willing to pay, which is the maximum price they'd be willing to pay. It's going to equal 150 minus Q. It's always easiest, I think, to draw a demand curve before you draw the supply curve. It assures that everything is sort of going to fit. And actually, you can draw it. The examples we're going to use in class are always just going to be linear. Right? You can draw the demand curve without even thinking about the slope. You just need to take up as much of the space as possible, and then you put in the axis. Right? The most that someone's willing to pay for a textbook here is $150, or perhaps $149. If you think the first person is Q equals 1, they're willing to pay $149. And if textbooks were free, right, what would Q have to be for willingness to pay to be equal to 0? Q would have to be 150. Right? There are 150 people here who would like a textbook if it were free. But there are some people who are willing to pay up to $149 for it. We do the same thing to work through the supply curve. Right? The supply curve has a vertical intercept of 10, right? No one is willing to accept less than $10 for the textbook. Maybe it's just not even worth putting in the mail or going to the post office for less than $10. But the first seller would be willing to sell their book for $11. They probably really hated economics. Second seller, $12, $13, and so on. So this is, of course, the supply curve, and this is our demand curve. Right? The first thing that we need to think through then is what's the equilibrium price and quantity going to be? Essentially, where do supply and demand curves cross? And this is a pretty easy thing to solve algebraically, right? We're going to solve to find Q star, which will be down here, and P star here. So to find Q star, right, we can just find where the quantity demand is going to be equal to the quantity supplied, right? We can say when is 150 minus Q going to be equal to 10 plus Q, right? Well, if we add Q here, subtract 10 here, we're going to have 2Q equals 140, which means Q star, the equilibrium quantity, is going to be 70 textbooks. every day there are going to be 70 textbooks bought and sold. That is going to go right down here. Right? Once you found Q star, you can take 70, throw it back into both these equations, right? No matter which one you throw it in, you should get the same answer, right? No willingness to pay for a 70th textbook is 150 minus 70 equals 80. And the willingness to accept, right, for the 70th textbook is going to be 10 plus 70, also 80, right? So the 70th textbook, someone is willing to pay 80 bucks and someone's willing to accept 80 bucks for it, right? That's how we know we solved the first part correctly. If we'd gotten different numbers here and here, we would have known we need to work through this problem again. It means we screwed something up in solving for Q star. But here we see that P star, right, is equal to both the willingness to pay and the willingness to accept. It's $80. All right, so now we found equilibrium price and quantity. There are going to be 70 textbooks bought and sold every day for $80 each. The problem asks you to consider an out of equilibrium price as well, right, of $100. Right? Imagine a price were $100. Why wouldn't this be something we'd expect to see in the market over a long time, say many days in a row? Well, the reason for that is that $100, there'd be a bunch of people who'd like to sell a textbook, but fewer people who would like to buy a textbook, right? That means the sellers would be noticing every time they log on to sell a textbook, they'd notice there are huge numbers of textbooks, of used textbooks already being offered, right? For Greg Mankiw textbooks, but there wouldn't be very many people buying them. That would mean some of the sellers would realize that they really want to sell their textbook, they're going to have to lower their price, underbid some of the other sellers. And that process will continue until there's no longer any excess demand. This is the excess demand here, the difference between the quantity supplied and the quantity demanded at any given price. And if, in the opposite example, imagine a price started out at $60, right, for a textbook. In that case, there would be a lot of demand, but not very many textbooks supplied, right? And some people logging on to sell their book would notice, hey, there aren't any books for sale here. I should raise my price above what the last person sold their textbook for. So that's what's going to get us ultimately to converge at this equilibrium price of $80, where 70 textbooks are bought and sold every day. You're also asked to work through and calculate the consumer and the producer surplus in this model. And here, what's important to recognize is that consumer surplus is all this area up here, this whole triangle above the price, and the producer surplus is this area down here, right? It's easiest, I mean, you could add this up. You could say the consumer surplus for the first person, when quantity equals 1, right? They're willing to pay $149. They only had to pay $80, and so their surplus was $69. And the second, you could add that to the second person, their surplus is going to be $68, then $67, and so on. But it's easier just to use a little bit of algebra, right, or a little bit of geometry, right, and calculate out the size of this triangle here, right, where we're going to have consumer surplus is going to be equal to 150 minus 80. This triangle is 70 high times, it's exactly actually 70 wide as well, right? And then since it's a triangle, to get the area, you have to divide it by 2, right? That's going to be equal to the consumer surplus. And you, of course, work through exactly what that is on your own. The producer surplus is similarly, actually, in this example, going to be 70 high, 70 wide divided by 2. It's going to be exactly the same. And in fact, anytime you're given an example where the supply and demand curve had the same, same slope but negative, right? The slope for the demand curve here is -1, the slope of the supply curve is +1, and so you can get the same consumer producer surplus in those examples. That's just by chance, and it's an easy problem for me to give you. when you work through the final example here where the demand curve shifts out, the slope does change, and it means the consumer surplus and a producer surplus will be different, right? But this is what the consumer surplus is going to be. 70 times 70 divided by 2, right? In both cases, those equal what? 70 times 70 must be 4,900, so they're going to equal 2450, I think. Unless I did that wrong in my head. I don't have a calculator here for me to make sure that's exactly right. I think that's correct, though. So that's how you can do the producer and consumer surplus. You're asked to also think about whether or not this is an equilibrium. And the important thing to recognize is that no one has an incentive to change what they're doing. So it is a Nash equilibrium in the sense that we thought about in Unit 4. Right? Imagine there's 70 people buying and selling textbooks at $80. Does anyone have an incentive to change what they're doing? Well, all the consumers who bought a textbook, right, have no incentive to change what they're doing because they were all willing to pay more than what they had to, or the last person was willing to pay exactly what they had to purchase the book, right? But all these other consumers clearly have no incentive to change what they're doing. And same with the sellers, right? The sellers are all happy to accept, a price is literally $11, $12, $13, right? The last seller is maybe indifferent, right? They're willing to accept exactly what they get, the $80, right? But every other seller has no incentive to change what they're doing. And there are people, of course, who would like a textbook who don't get one, right? These are people down here who are willing to pay $79 or less for a textbook. But none of them are better off than paying $80 for a textbook. That's what the market price is. None of them are going to change behavior and buy a textbook for more than what they're willing to pay. And there are also a bunch of people who don't sell their textbook, right? But those are people who kind of liked economics and decide they want to keep their textbook going forward. If the price went up, they might sell, but at a price of 80, this person here is willing to accept a price of 100, for example, but they're not willing to accept a price of 80. So in that sense, this is a Nash equilibrium, just like the Nash equilibria that we analyzed in Chapter 4. So finally, the last part of this problem, what you're going to do on your own, is you're going to think, what happens when this demand curve shifts out, when I give you a new equation for the demand curve? And intuitively, right, what that's going to do is it's going to increase the equilibrium price, and it's also going to increase the equilibrium quantity, right? Is that change going to be efficient or fair? Well, it is going to be efficient. Right, in competitive markets, we always get to efficient results because the supply and demand curve intersect, right? And where they intersect is the price and quantity that maximizes the total surplus, the consumer surplus plus the producer surplus. Whether or not it's fair is much more difficult to say, right? What we know here is that there are some people who would like a textbook, right, who are unwilling to buy one at the price that they're given. And that might not be fair, right? It might be that these are students who just don't want to study economics, don't need a very good grade or whatever, and you might say that's fine. Some of them, though, might just be poor students who don't have $80 to purchase a textbook, right? That might not strike you as fair. And when demand shifts out and it raises the price further, right, then there are going to be some people here, right, who were willing to purchase a textbook at $80 but aren't going to be willing to do so at a higher price. So the fairness of a competitive market is not clear, but the efficiency is. As long as the total surplus is as large as it can be, right, we could not be better off. We could not increase the total surplus by choosing some other price and quantity. So that's the basic mathematics of homework 3.1. I encourage you to work through the last part on your own.